Hello ladies and gentlemen, my name is Decryption and I hope you are well. Have you ever seen it in games where you can just randomly type a code on the keyboard at any point and cheats will activate? So in Sims you can type Motherload and you'll get loads of money, or in San Andreas you can type such as celebrity status to spawn a limo, blue suede shoes to make everybody spawn as Elvis, crazy town to make everything clown themed, and many more. So in today's tutorial we're going to be looking at how we can add that into our game to add just cool random cheats that people can put in to really activate different stuff. And we'll make it activate anything from big head mode to giving the player some money, and this will be available in-game, a proper cheat system. So let's get started. So the key way this is going to work is we need to capture the keys that the player types in and remember what they are temporarily. Because if you're typing in, say, Motherload to get money, you need to make sure that the player's pressed MOTHERLOAD kind of thing to get the money. That's of course if you want the real-time typing aspect. If you wanted to create a menu where you type it in and do it, that will equally work too. But in this tutorial we're going to focus primarily on the typing aspect, the old school way you used to do it. And in part 1 of the tutorial, we'll focus on typing the letters, and in part 2 we'll add cross-platform compatibility. We can press controls and stuff like that. So the key to this is remembering what the player's typed in. I'm going to open up my pawn, because I've got a bug on my controller where it won't remember the keys I've pressed for some reason. And the key thing we need here is no specific key, but we actually need the event any key here. And this is going to fire every single time we press a key. So if I print out here, and from this, just do get key display name, I can plug that into this here. And you'll see, as I start pressing really anything, it will print down every single key I've pressed at the side. So as I press W, it'll press W. If I press S, A, D, space, everything. So if I, for example, wait till it clears away, and if I type new, you will see it's gone NEW, or testing. You can see, apart from my inventory loading up, it captures the keys. So what we're going to do is modify this here so it logs and has a very small memory window where it can remember everything you've typed, and then it'll keep resetting the timer, watching the cheats that you type in. And if any one of them equal one of the cheats you've got, then it will activate it. So I'm going to delete off this print statement here, and I'm basically going to promote this return value to a variable called recent keys, like so. And I'll make it, and it doesn't need to be instance editable, I can actually make it private. And I'll put it in the category of cheats, just so it's nicely tucked away. I'm actually going to unbind it and delete the set, and then I'm going to right click it to turn it into an array, because then we can track multiple of them. I'll drag off and do add, and we don't want to do add unique because some words may have the same cheat codes in, and I'll put that there. Next, we actually need to keep track of the actual word that we're building up, because we need to build the word up as you press the key so we can try and find if it's a valid cheat code. So then I'm going to come and create another variable called cheat text, and this one will be a single value, and I'll put it into cheats like so. The first thing I'm going to do is set the cheat text to be blank here, because we're going to use this as basically a caching variable. So every time you press a key, it will add the key to the current list of keys, it will build up all the keys into the cheat text, and then if the cheat text is of a certain length, it will then try to see if it's a cheat. So that way, you're not searching a data table or whatever you're going to use every time you press W. You're only going to search it if you press like 5 keys at once under the time limit, then it will search for it. So the first thing we'll do with a caching variable is we'll just set cheat text to nothing. Then we're going to loop over all of the recent keys. So I'll just come and do for each, and I'll plug that in over here. With this, I will then grab my cheat text, and then I will also set the cheat text at the end here. I'll drag backwards off of this and do format text, which is why I love text, it's so easy to do. And then inside here, I'm going to type the very specific characters, curly brace, and I'm going to call it whatever you want, I'm going to call it old, close curly brace, then open curly brace, new, or whatever you want, and then close curly brace. The curly braces is the important part. I'm going to link that to the loop body. I'm going to plug the cheat text into the old and the array element into the new. So this is just a really quick way of building up all of the stuff we've typed in with the keys and adding it together to create a single value. So if we type M, it will run through all of this, clear the cheat text off, loop over M, and add it to the text. Then we type O for Motherload, it'll do the same thing, clear the text, and then put MO into the cheat text. So that's how we slowly start to build it up. The next thing we need to do is actually clear it off if the player doesn't type anything quick enough. Because you can't type M, wait 20 minutes and type O and keep the cheats going on. You have to be fairly rapid. So what I'm going to do down on under the completed is I'm going to set a timer by event. And I'll set this time to whatever I want it to be. You could justify this depending on your difficulty. I found 0.5 to be pretty okay in my opinion. And then I'm going to promote this to a variable called cheat timer. And I will also make this private because it doesn't need to be used anywhere. So the reason we've promoted it to a cheat timer is every time the player presses a key, if it's finished looping over everything, it's going to cancel the timer we've just set up. So we'll just drag off and do clear and invalidate timer. So the timer will reset itself basically because now we'll plug it back in. So if 0.5, half a second's going down but they type a letter, it will rerun back through it, clear the timer, reset the 0.5 timer. And then from here we can come and add a custom event called check cheat. And the first thing I'm going to do is check the length of the cheat text. Because if it's less than 5 characters, we don't really need to query the data table. This is how we keep it really lightweight. So now that we've got our timer, that's going to check if the player's run out of time. I'm going to create this event, so I'll do add custom event, and I'll call it cheat expire. So if it gets to this 0.5 point, it needs to remove the cheats. So all I'm going to do is set the cheat text to be nothing. I'll set the recent keys and I'll clear them. So you've lost all your current keys because you've not really met the cheat text criteria. And then I will also deactivate the cheat timer by clearing it like so. So now this gives us a very basic concept where we log every key they press, it builds it up, and then starts a timer. If the timer runs out, it removes the cheats. So how do we actually check if it's a valid cheat? So what I'm going to do is after it sets the timer here, I'm going to get the cheat text and I'm going to get the length of it. But we can't do it directly, so we have to convert it to a string first and then we can get the length. So the first thing I'm going to do is check the length of the keys we've typed in. Because if you just type W, then you don't want to check the data table just because they've pressed one key. You might not want to do it 2, 3, 4 either. The longer you leave it, the more performant it will be because you don't want to be checking a data table very rapidly. So what I'm going to do is drag in my recent keys and I'm only going to run it if the length is greater than 5. So all of my cheat codes will be greater than 5 basically. So let's plug that in. So if it's less than 5, we're going to do nothing. We'll just let the timer continue or the player retype what they need. However, if it is more than 5, then we can actually crack on and check the cheats. So there's multiple different ways you can check the cheats depending how complex you want it to be. You can have a data table that you query. You can have an array in a variables that you also query. What I'm going to do is actually a mixture of both. I'm going to have a data table which lists all my cheats and then the commands they're going to run to activate said cheat. But I'm going to store those data table row names in memory as the player's testing more than 5 cheats. And then that way it only has to query the data table once until it finds a match. So let's get started with our list of cheats. I'm going to come to my blueprints folder and I'm going to go into my structures. Inside here I'm going to right click blueprint structure and I'll call it s_cheat commands and I'll open this up. Inside here I will put the cheat description. So this will just be a developer friendly thing that will tell us what the cheat needs to do. We could also make it prints out to the UI if somebody unlocks a special thing, like a menu or something. And then the next variable is going to be a blueprint that's going to spawn in, activate the cheat, and then disappear. It's a nice quick way to have it run, so we can store all of the commands in the data table. Equally, you can do it another way if you want to use a function library and parse it, or if you just want to use the cheat manager that's built into Unreal. So I will call this cheat blueprint. So we need a type for this. So I'm going to come back into my blueprints folder. I'll go into my MISC. I'll create a new folder here called cheats. And inside here, I'll create a blueprint class, actor, BPA, game, cheat. And I'll open this up. I'll set this to a type of abstract class so we can't use this directly. And I'm just going to come and create an event inside it called activate cheat. And I'll just compile and save. That's all I'm going to do. Back in the cheat command, I can now set this to our BPA game cheat. But I'm going to set it to a type of soft class reference. So we actually spawn it in. Now that we've got our struct with our game cheat, we can come back to our data tables folder or create a data tables folder. Right click miscellaneous data table. And I will search for our cheat command and I'll click OK. Now I'll call it DT game cheats and I'll open this up. So now I can create a list of all the different cheats we want to run. So I'll click add at the top. I'll set the row name to the command. So in my case, I will do Motherload. The description, I will come and set to gives the player, 10,000 gold. There we go. The cheat blueprint is how we actually run and activate the cheat we want to use. This gives us the ability, using blueprints, that if you want to spawn a giant monster in, like you have to fight, then you can just spawn that monster in using the cheat blueprint. Or if you want something that continuously runs, like it keeps spawning wave after wave after wave of enemies, the blueprint can spawn in and just not clear itself up. So it makes it nice and easy and very flexible. So how do we create a cheat for it then? So I'm going to come back to my BPA game cheat. I'm going to make a child of this one and I'll call it game cheat underscore Motherload. You call it whatever you want. I'm just going to call it Motherload. In the event graph, delete all of these. I'll right click and do activate cheat. And you'll see an event to add an event called activate cheat. Don't click the call, you want the event. So we'll click that. I'll then right click and choose add call to parent function. This is just in case you want anything that all cheats run at the same time. So maybe you want to log that the player has used cheats, in which case you can do it here once and then every cheat will follow it. So in here, how do we give the player money? This is entirely dependent on your game. On my game, I have the narrative inventory. So I'm going to get the player pawn. I will get the inventory component. And then I will simply add currency. So this cheat is going to give it 10,000 gold. So I will go 10,000 gold. And then all we simply need to do to keep it clean is destroy. Just like that. And that's it. There's our first command, cheat done. So to use it, we'll go back to our data table. I will assign it in here. You can see the Motherload cheat. Back on our character. Now that we've looped over 5 keys, we actually need to search this data table to find the cheat now. So I'm going to drag off of the true and do get data table row names. I'm going to select our cheats data table. And now I mentioned an optimization a minute ago. So what I'm actually going to do is promote this row names to a variable called cached cheats. And I'm going to make sure it's private and in the category. And the reason I'm doing it this way is we don't want to get this data table in memory every single time we want to check it, because a data table is going to take a little bit of time to load. It's on disk, it's not in memory until we tell it to be. Whereas if we promote it as a variable, it means our cheats can be nice and snappy until we don't need it anymore. Then it can just be cleared off like normal. So, just before we do this, I'm going to drag in the cache cheats and say, is it empty? If it's empty, so true, then I'm going to go to the data table and get the cache cheats like so. However, if it's not empty, then we don't need to deal with the data table at the moment. We can just deal with the cache cheats. So in here, I will do find item. And the item we want to find is our cheat text. So you see, we won't be able to plug the text in from what we've typed into the cheat here, the row name, because Unreal's data types aren't compatible. But what we can do to get around it is convert this to a string, and then the text can be converted over like so. Equally, what you could do is convert it here when you build it up in the first place, based on the keys, but I figured doing it once here as a complete thing, instead of looping over and doing the conversion over and over again, is going to be a lot neater to do. So now that we've tried to find the cheat, if you hover over the find, it'll tell you, it will either tell you the index, so 0, 1, 2, 3, 4, blah, 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 or it'll report -1 if it's not found it. So I'm going to drag off of this to do equals, and say, if it equals -1, then it's not found the cheat. This might be because the player's typed it wrong, so they might put mother money. It equally could be that the player hasn't finished typing yet. So we need to account for both. If it's true, it's not found the cheat, we'll just ignore it for now. However, if it's false, then it means it's found the cheat. So we can actually now use this. So now that we've found the cheat, we can actually use the data table. So on false, I will do get data table row, and we just want the row. We don't need the names now. The row name, we can just drag off the converted name here. And the data table is our cheats data table. And now our out row, if we break on it, will successfully have the cheat blueprint we can use. So if we drag off of this and do async load class asset, plug that into row found, from the completed, we can do spawn actor from class. The class is going to be our cheat blueprint. Like I always say in my tutorials, make sure you have the async load asset on the completed first, otherwise this will not resolve properly, it will error. And then the collision handling we can just set to always spawn, and that's it. There's the cheats. We can do some clear up, so once it's cached all the cheats, chances of the player retyping a cheat in again is going to be slim. So I'll get the cached cheats and I will just clear this. And we can also go off and clear everything else. So I'm actually just going to come and call the cheat expire function there. So it'll wipe all the previous keys off. So we'll go cheat expire. We need a transform, we'll just split it. It doesn't matter where it spawns really. So the final thing we need to do after we've spawned the cheat is to simply tell it to run. So I'm going to drag off of this and just call activate cheat. You might be wondering why we don't just stick it on event begin play. And you possibly could stick it on there. But if you have anything on the spawn actor that you want to add to it, maybe it has to find the player, maybe it has to do something else, having it on the event begin play means it's going to run without your say-so. At least with activate cheat, you've got a bit of leniency to call it yourself and tell it what to do. So if I come on and play it now, you can see if I move around, everything's working as it should. If I wait for the cheats to clear in half a second, now if I type Motherload and press the tab key, you can see I have now been gifted 10,000. And just to check if it's working again, I'll wait for the keys to clear, Motherload. And now I've got 20,000 gold like that. Motherload in a basic cheat system. How cool is that, ladies and gentlemen? We can do some more optimizations to it to make it lightweight, because this is running every single time the player presses a key. It's going to be quite heavy if you keep doing it. So one of the optimizations I'm going to make is we're already checking if it's over 5 there, and then we're testing the cheat. There's going to be a limit to what we need to type, because if they keep pressing keys over and over and over and over and over again, they'll eventually hit the limit on what a text or an array can be before it runs out of memory and crashes the game. We don't want that. So what I'm going to do after we've checked if it's over 5, before we actually go off and check the cheats, just to make sure nothing's glitched out, for example, they've been pressing keys non-stop for 20 minutes, I'm just going to simply check, is it over 20? If it's over 20, it means that we've just not cleared it in a while because the player's been actively pressing stuff. So from this, I'm just simply going to call cheat expire, like so. Otherwise, if they haven't done that many keys, then we can simply tell them to check the cheat again. So that's a nice little optimization there to stop any major bugs. Another one we need to do is at the moment it's caching the cached cheats here, but it's never actually getting rid of them, except if you ever put a proper cheat in. So what I'm going to do is also clear it on cheat expiry. So I'll drag it across over here and paste it right here as well. So now it's got plenty of time to clear up the cached cheats. So I'm going to make all of these instance editable just so we can see how it works. So now if I play the game here, we should be able to see the variables going up and down as we play the game. And if we get too far, then you should also see it take itself away. So if I click my player here, you can see the cheats right there. The cheat text will say false for some reason. I don't know why, but that doesn't matter. The cheat timer, which we're not going to be able to see. The cached cheats is the cheats we're going to be using, and the recent keys are the ones we've pressed. So as you can see, if I press the right mouse button, we can build it up. And as it gets to 18 or 20, whatever we set it to, it automatically clears itself, just assumes the player's playing the game. So if I'm running around, it's building it up, I can jump, I can press buttons, and then it gets too far and goes, actually, you're not pressing a cheat, just clear yourself off. But if I let it die down and type Motherload, you'll see it activated the cheat nicely. Look, you can of course add notifications and stuff like that you want. That's all good too. So there we go, ladies and gentlemen. So let's add some more cheats to it then. So one of the most common ones that I absolutely love myself is big head mode. So I'll type big head mode. It doesn't matter if they're in capitals, it will still find it. But just to make sure it will find it, after we've added all the cheat keys here, and before we're about to check if it's a valid key, all I'm going to do is get the text and set it to uppercase like so. So just before we check the actual array or the data table, we'll make a little bit of space. I'm going to promote it to an uppercase and then set that back to the cheat text. This just ensures that if for some reason Unreal decides to not check it in the correct way, or a different localization issue might arise, this will prevent it from actually doing anything. But let's get back to big head mode. So big head mode, the description, everybody has big heads. There we go. The cheat blueprint, let's go and create it. So I'll duplicate the Motherload one just for now, and I will call it game cheat underscore big head mode, and we'll open it up. I don't need to do any of this, but I do need to keep the destroy actor. So there's a couple of ways we can do this now. So we can loop over every single actor and tell them all you've got big heads. And that'll get all the actors here. But as you run through the game, new characters are going to spawn in. And as they spawn in, they won't have big heads because they've not been told to have a big head. So I'm actually going to approach it a different way. I'm going to create a repository of where we put activated cheats in. And then anybody who needs to look for it, say our NPC spawner, can check the currently active cheats and then spawn the correct ones. So I'm going to come into my game instance. If you've not got a game instance, just simply come to your content drawer, right click blueprint class and search for game instance. Click game instance and give it a name, and then finally go to edit, project settings, maps and modes, and just set it there. That's all it is. A game instance is good because it doesn't get destroyed at every level. It transports itself across the entire game. So if you go back to the main menu and come back in, it will have cheats activated, which is exactly what we want. So I'm going to come to the variables here, and I will put activated cheats. I will set it to a text, and I will right click it to set it to an array like so. So now we can store all of our activated cheats in there, only the ones that need to be stored in there. We don't want to store everything. So Motherload, we don't need to activate it. It's a one-time cheat. Big head mode is an activation cheat. We want to keep it in there. So we need a way to get our game instance activated cheats, and luckily I've already assigned an interface. So I'll open this interface. I'll add a function called add activated cheat. The input will be the cheat name, so I'll just put cheat and it'll be a type of text. We also need to check if the cheat's active, so we'll do get activated cheat, and in the inputs we will again add the cheat. So this is the one we're checking for. So on our animation blueprint we will check, is this cheat active? And then finally we need to be able to remove it. So if we type the same one again, it removes it. So I'll add a function remove activated cheat, in which case I'll just add an input of cheat again. Type of compile and save. Back to our game instance, I can implement these interfaces. So remove activated cheat. Let's get our activated cheats and simply call remove item, passing in the cheat. There's that one done. We can add activated cheat, where we do the exact same thing, but we call add and we connect to it like so. You could also just call toggle and make it do both. I don't mind either way. And I'm also just going to do get activated cheat, and get activated cheat needs to actually return whether the cheat's active or not. We don't really need to know anything past that. So what I'm actually going to do is go back to my game instance interface, and on get activated cheat, I'm actually going to return a boolean of is active. Compile and save. And now when we double click get activated cheat, it'll be a function. And what we can do is get our activated cheats, say find item, plug in our cheat, and just like we did before, if it equals -1, it's not found, it meaning it's not active. So we'll reverse this and plug it into there. So what this is going to do is come in and say, but get the activated cheats and find our cheat. So this will come in and say, does it equal -1? If it does, then we need to return false because the cheat isn't found. So we reverse the true because it's found -1, because it equals -1, then it will return false. Otherwise, this will be 0, 1, 2, 3, 4, 5, which will reverse to a true and return is active. I hope that makes sense. So in big head mode here, this is a permanent cheat. So we can right click and do get game instance. From here, we can drag off and we can do add cheat, activated cheat. We know what cheat this is because it's big head mode. So we can type big head mode and we can plug that in to destroyed actor just like that. But what we can also do, which will be quite nice, is when this is spawned, if the cheat is already active, we can take it off again, which would be quite nice. So what I'm actually going to do is make some space here and get the game instance again, and I'm going to do get activated cheat. And if the cheat is active, so I'll add a branch, that's mob, we don't want that one. So is it active? If it's false, because it's not active, then it can add the cheat. However, if it is active, then we can remove the activated cheat instead. So we can plug it into true and then make it destroy as well. So now our activated cheats really easily can add themselves if they exist, or remove themselves to turn them on or off. If you don't want your cheat to be able to turn itself off, just don't add this bit. Equally, if you think all of your cheats are going to be on or offable, you can add this logic to the activated cheat instead. So finally, how do we actually activate big head mode? So this is going to be depending on your characters, but I'm going to come to my character here and I'm going to open his animation blueprint. Inside the anim graph here, just before the output pose, after you've done all your calculations, because if you do it before default slot, his head will shrink back down as he animates, then grow back up again. It'll look weird. Then from here, I'm going to drag off and do local to component. For some reason you have to do that. I still don't know why. I'm not an expert on the animation graph. But then what we're going to do in between here is called transform bone, or modify bone. The scale we will come and set to 222, then we'll plug it all back in. The important thing is to click the node and scroll down to scale, set the scale mode to replace existing, and then the bone to modify, set it to your head. And in theory, that should be it. So as you can see, it has successfully scaled his head. He now has a big head, but that's permanently on. We don't want it permanently on. So we'll come back to the event graph. So how do we check if our cheat mode is active? Well, we've already got this back on our game instance here. So we'll get the activated cheat, and we can hard code this in the animation blueprint because we're looking for something specific. So I'll add the game instance in. I'll add this to the sequencer here. I'm not a fan of doing it this way, but it's just a quick thing for now. We'll promote this to a variable saying is big head mode, and that's it. So now we can get the activated cheat. Is it big head mode active? Back in here, before we go local to component, what I'm going to do is drag off and do blend poses by bool. If it's true, then we want to add this component to local code before it, like so, and then we plug this into the output. We can now put this default slot code over here. However, if it's false, then we just don't do the above modifications. We literally just plug in our normal code like so. I bet if you're an animation graph wizard, you could probably promote that to a cached pose, maybe. I don't know. And then is big head mode, I'll just plop into there like so. So if I run it now, you can see normal head mode. But now, if we come back into the game and we start the game, if we type big head mode, everybody's heads should now read that we've got an activated cheat and grow massive. So you can see, everybody's normal. You ready? Big head mode. Interesting. And the game typically works a lot better if you actually assign the blueprint to it. So we'll go back to big head mode, compile, save, let's try it again. I was getting loads of errors for that, not wondering, took me a bit to figure out why, but if we try it now, see, everybody's normal. But if we type big head mode, boom, everybody's got giant heads, ladies and gentlemen. There are some which don't have it, and that is purely because they've got different animation blueprints. So you can see big head mode, and all the animations should work. So if I talk to you, oh, okay, he's gonna follow me, he's not gonna talk to me. Let's do it to the other guy as well, to the other animation blueprint. So he's got a different one purely because he's an ALS type of character, but the code should be the same. So I'll go to the anim graph, right near the end, I'll copy this code here for modifying his head and the slot. I'll paste it right at the end here, connect it up to there like normal. Promote is big head mode to a variable. Give myself some space back over here, connect that. So it's not going to let us connect all of that together, so I'm actually going to promote this to a cached pose. So new cache pose ALS body, and then what we can do is just before this call ALS body, and then we can also do it down here as well. There we go. So now that one should work. All we have to do is add the final event graph code in, which is just this bit here. Add it to the bottom of the ALS guy. So I've got nothing but anim notifies on this one. So I'm just going to add a update animation. I think it's using C++ stuff, so I'll add a call to the parent, passing in the delta time, and then we can just add our code. So in theory, if we compile and save, as long as ALS doesn't do anything funky, we should have big head mode on ALS as well. And we should be able to deactivate it, which will be even cooler. So you should see, if we now come back into the game, if we type big head mode, every character, including the ALS and the standard NPCs, should have big heads. Big head mode. There we go, ladies and gentlemen, our player included, everybody has gigantic heads. And it will all animate the same, that's the cool part of it. So if I come to this guy here, the shopkeeper, and talk to him, he's got a giant head. His animations will work as well, I just don't have animations on it. So you can see, I can help him with his quest, and everybody will have big heads. Even the guards who are randomly roaming around will have big heads. If we run to the jail, you will see the guards in there also have big heads. There we go. One of the best old school commands ever, big head mode. The helmet's increased size as well, which just makes it look that much funnier. And there you go. And if we type big head mode, everybody's heads shrink back down to normal. What do you think, ladies and gentlemen? We have now got 2 proper in-game cheats for our game. You can really do anything you want with it. You can teleport players around, you can interface with any object you can with blueprints. That's how cool it is. If you've got any suggestions for cheats you'd like to see me add, please let me know below. Thank you for watching, ladies and gentlemen. I hope this helped. If you've got any issues, please let me know. My name is Decryption, and I will see you next time.